we are ready. So we are a little behind, but we will try and ask our, and I forgot to mention our home team, California, is up after our colleagues from Hawaii and Washington. Derek Chow, you've been here since very early in the morning, your time. Thank you very much. Derek, I would say that of all of our communities and states, you in Hawaii are probably the most vulnerable to sea level rise, and you don't really have a lot of running room. So, Derek, you are the Deputy Director at the Hawaii Harbors Division, and how do you address this problem?
Well, thank you, Stas. I'll go ahead and start showing my presentation, but what I'd like to do today is share with everyone the analysis that we've been doing with regards to sea level rise and kind of leave you with what decision point we're left with. So with that, let me go ahead and get started. First, I want to say aloha to everyone. Good morning, good afternoon from Hawaii. And as Stas has mentioned, yes, we are very vulnerable. We are in the middle of the Pacific Ocean. I'm trying to move my screen here, just a minute. So we are in the middle of the Pacific Ocean. We are 2,000 miles from the continental United States, the west coast of the continental United States. And we're 4,000 miles from the Asian continent in the Pacific. So we're in the middle of Pacific. There are other island communities, island countries within the Pacific. But as far as, resources, as far as natural resources, they, like ourselves, have very little. I think the biggest natural resource we have is geothermal, and that's still something that hasn't really fully been developed and used. So we are in the middle of the ocean, and we are highly, highly reliant on the import of goods into Hawaii. So this slide shows in the red dots the 10 commercial harbors that we have throughout 6 of the major populated Hawaiian islands. There are many, many, many small boat harbors, but we are responsible for the commercial ports here. We are fully funded by fees and tariffs that we collect from our users and our tenants. So we're self-reliant, and we do not get any monies from the state general fund. So why is the harbors important to Hawaii? Well, as I showed you in the previous slide, we're in the middle of the ocean. We have no land connection. We can't bring things into the state of Hawaii by road. We can by airplane, but majority of the goods that are brought into Hawaii comes over by the ocean because of its cost effectiveness. But 80% of all of the goods that we consume in Hawaii is brought over into Hawaii. And of that 80%, almost all of it is brought over by a ship. Our ports provide not just our cargo services, but we also service cruise ships, commercial fishing. We do have small shipbuilding and repair industries here. We have marine research. We have a University of Hawaii that has a large research facility here. And we also support the military. Many people don't realize that for the Indo-PACOM region, the military depends a lot on the state of Hawaii and depends a lot on the port of Honolulu to ship its goods from here to Guam, to the Northern Marianas, and to other parts of the Pacific that so rely on the military, the United States military. This was our first project that really took into account sea level rise. This is the Kapalama container terminal. The advantage we had here is that it's a new terminal. It's built in a former Kapalama military reservation where the Navy had wooden warehouses that were stocked full of military goods. We purchased that many decades ago. The first phase of it, which is the bigger block in this slide, more the orange color, we basically demolished all of those large termite-eaten warehouses, and we paved it in concrete. We looked ahead and said, we need to have this to be a long-lasting, resilient terminal. So we paved it in concrete and not asphalt. We also raised the elevation from a plus, about a +6 to a +10 now. So we're several feet higher. The tidal range in Hawaii, because we're close to the equator, is about 2 feet either way, 2 feet up, 2 feet down. So if you're a boater, you like it during high tide. If you're a surfer, you like it during low tide. So people here are very, very much interested in how the tide fluctuates. On the right side of the slide shows you in the yellow boxes, phase 2. We are embarked upon a new construction project that's going to build out the shoreside areas of this particular terminal. And I'll get into more of some of those items later. So this shows an analysis that the state and the counties have done on sea level rise predictions in Hawaii. The bottom line shows what an earlier prediction was. So by the year 2100, the prediction was a little better than 3 feet. After more serious analysis, after I think folks have looked at what else was happening around the world, they realized that that was probably a little understated. So they adopted the higher projection shown in the red, and now in the year 2100, they're predicting a sea level rise about 6 feet. Now, why is that problematic for us? Well, you know, we have 1.4 million people here throughout the state. We continue to ship 20 million metric tons of goods to the people. So if sea level rise impedes any of those activities, we would be causing a lot of impacts to the 1.4 million people in our communities. This slide shows our second busiest harbor on the island. It's Kalailoa. It's on the west side of the island of Oahu. And the reason why I'm showing you this slide, this is the harbor that we're now truly considering how sea level is going to adversely affect it. In the back part of the slide or upper part of the slide, you can see some of the gray boxes where we're predicting that some of the piers, existing piers, are too low and are going to be affected by sea level rise. So we have to think about how we're going to improve and modify those piers in the future. I really like this graph because I think it tells a big story here. So on the left basically is the piers as they exist today, and the upper boxes above that, the lighter gray boxes, are increments of the piers that we might construct over the years. But I think the big story is that a lot of our existing piers are pile supported. And today, as we have a 2-foot fluctuation in tide, those piers are sufficiently high. And not only are they sufficiently high for operations, from a maintenance standpoint, they're sufficiently high so that we can get underneath the pier. But as sea level starts to rise in 20 years and 30 years and all the way out to the year 2100, the piers will become underwater. So not only are we going to have operational problems, we're really going to have a lot of maintenance problems. We're going to have difficulty getting underneath these pile supported piers. So what we're projecting to do is sheet piling all of the piers and creating bulkheads, filling it up with filling behind it, and having all sheet or bulkhead type piers rather than pile supported piers. That alleviate us having to do maintenance on the underside of these pile supported piers. Now that's easier said than done. You know, what we're considering, of course, are physical modifications to harbor's infrastructure, primarily raising the heights of these piers. But the question is, you know, how do we do it? I mean, we're going to do it incrementally. We're going to do it fully. We've got to take into account how the vessels that use these piers are going to adapt to the way we change their operations. In those areas that are used just for barges, the piers need to be low, need to be about 2 foot above water level. So because the operators use a ramp, and they drive cargo on forklifts and top lifts on and off the ramp to get it onto barges. But in those areas where we have vessels that bring in the cargo from the US mainland or from Asia, we have to have a pier that is higher to match the heights of some of the boats, as well as to support the gantry cranes that are existing and that we'll be bringing in at those piers. So we have a lot of things to think about as far as how do we incrementally or fully modify our infrastructure to support our future needs. Now, one of the ideas that we're also thinking about is how do we get rid of having to, think about this in the future, at least for a long time, and is it feasible to even construct maybe an inland harbor, which would be where the water level would be controlled by a lock and dam structure, and what is the cost of that going to be? What are the environmental impacts going to be? So, do we incrementalize the way we deal with sea level rise, or do we fully build at what we expect the height of and rising sea to be, or do we fully mitigate it by getting ourselves away from the shoreline? So those are the things that we're toiling with at this time. As was mentioned in the earlier presentation, we're looking at risk versus cost. If we incrementally change the heights of the piers, then of course we'll probably have to do that multiple times during the life of our infrastructure. And so we'll go through multiple cycles of planning, design, and construction. We may also, and the benefit to that may be to allow the shippers to continue to use existing equipment that they have today. But incrementalizing any kind of modifications at the pier are going to cause numerous disruptions to the operation. We're going to have to move people from one area while we modify it and move them back. So there's going to be a lot of moving pieces if we incrementally change and modify these harbors. On the other hand, if we fully modify the harbor and build it up to what we expect the full rise of the sea level to be at a certain point, say the year 2100, then there's large costs up front. And not only are there large costs up front for us building the infrastructure, but there's going to be costs for the operators as well. And as I was saying, for those barge operations that use top lifts and forklifts to drive cargo over a ramp to load the barges, they may have to go to a crane type operation. So there's great expense on equipment. There may also be great expense on vessels as well. They may discontinue using barges, and they may now have to use vessels. And of course, the harbors in the outer islands, the neighbor islands, they're smaller harbors, so they're going to have to build special vessels. They can't use the same vessel that brings the cargo in from the U.S. mainland or from Asia. They're going to have to build special vessels that can operate and function in the neighbor islands. So there's a lot of different things that we have to consider. And of course, what is the cost? And who's going to pay for the cost? And as I mentioned earlier, we're a self-sufficient entity. Our revenues fully come from the harbor fees and tariffs that we collect. And so, we'll be taxing our tenants and our users a greater deal if we truly want to, build larger projects in the future, larger costly projects in the future. So we're looking into, where can we get federal help? And that's where, the Corps of Engineers comes in. This year, we're expecting a new start feasibility study for a Honolulu Harbor modification project that's going to look at modifications not only to expand the cargo fleet, but also to adapt to a changing sea level, as well as to maybe address some of the emergency issues that we have here. Now, aside from sea level rise affecting the shoreline, we have to be respectful and coordinate with others around us who we depend on. Of course, our partners at DOT highways and county roads that connect up to the harbors, they'll have to adjust. The Department of Land and Natural Resources, I mentioned the numerous small boat harbors, they'll have to adjust as well. They, of course, are responsible for shoreline management. Even though we may be addressing our parts of the harbors, adjacent properties that are not part of harbors will have to be modified as well to address coastal flooding. And in the counties, of course, with their local roads and the local services, they will have to adjust as well. So it's going to have to require a lot of collaboration, a lot of coordination amongst entities now that are almost fragmented and don't do a lot of interaction with each other. So in short, what I want to leave you with is that we are very much affected by climate change and sea level rise. We're totally dependent on goods being brought in by ships. If we don't, cost of bringing things in by another means, mainly air cargo, is going to be very expensive. But at the same time, modifications of our harbors to adapt to climate change and sea level rise is also going to be very expensive and also be, very disruptive to the operation. So it takes a lot of planning, and it's going to take a lot of money, and we certainly need to be reaching out to our partners, both locally as well as with the federal government. So pending any questions, that concludes my presentation.
Derek, thank you very much. I am intrigued by this inner harbor idea. And I think one of the questions going forward for the state is that if we were able somehow to make the bigger investment, would we see long-term benefits to the state? Because I hear you warning about the incremental problem of being constantly disruptive, of having to make constant changes, adjustment for equipment that works one day and may not be able to work the next day. Are you hoping that this Army Corps of Engineers study will help answer some of those questions?
Yes, thank you. Definitely. We've been trying to get a new start feasibility study of Honolulu Harbor for some years now. In fact, back at the time when I was at the Corps of Engineers. And what I'm being told this year is that it's in the Corps' budget. We're just waiting for, of course, the Congress and the President to pass the FY21 budget. With that, we at Harbors are prepared to ask the Corps of Engineers to study not just modifications to the channel and the basin, the main channel and the turning basin, but also to help us look at the possibility and feasibility of an inland harbor that may require, large acquisitions of land, large amounts of dredging, and the construction of a control structure like a lock and dam. And we would have to basically retreat from the shoreline and build, all new infrastructure inland for our main harbor. So yes, we do expect that the Corps of Engineers, we'll be asking the Corps of Engineers to take that up.
Well, just as it's kind of a parallel, but that's in effect what the Dutch did when they moved outwards. You're moving inwards, but the effect is that when they developed a whole new terminal complex, the productivity and the capabilities of the complex radically improved for the better. And I suspect today that even though it was an expensive investment, I think it cost around 8 billion euros, that they're very pleased with the outcome.
Yeah, you're right. And with today's COVID impacts, it makes the reality further and further away, because we're obviously not going to be able to balance the budget with all of the drop in revenues that we've experienced because of the COVID pandemic. So, these are serious decisions that we have to make, not just for now, but also in the long-term future. And we're obviously going to be, placing the burden on the cost of this on future generations. So it's a serious decision that we're embarked upon.
Okay, very good. Derek, please, if you have new information about this, would you send that to me? I'm very interested in getting the information out about this. I think you've raised a very intriguing possibility that many of us should be thinking about in terms of new strategies.
I certainly will. Thank you.
Thank you. Okay, Arvind, do we have a question?
Yes, there's a question for Derek. It's a long question. I'll read it. Derek, you referenced the many groups on the shoreline who all have different responsibilities and different priorities. Should one group make an improvement, it could improve conditions for an adjacent group. Do you see the likely solution to this would come from a grassroots perspective, example, develop interagency agreements, or more likely a top-down perspective, example, federal?
So without airing too much dirty laundry, let me tell you that several years ago, when I was still at the Corps of Engineers, one of the things that we did at the Corps of Engineers is we sponsored basically a conference amongst folks that were interested in climate change and sea level rise. And it was for the benefit of the State Office of Planning that is tasked with, you know, given the responsibility to address climate change and sea level rise policies. So we did, the Corps did, and what came out of it was a lot of recommendations that the State Office of Planning has then since adopted. They've developed policies, and they've even gone as far as to have legislation passed. So today, there's the State Office of Planning Climate Change Office, and they're responsible for that. They have a new administrator that was just put in place this year. He came out of the energy sector, but he's now at the Office of Planning Climate Change Office. So we're looking to them to help us all, you know, be better connected and collaborate.
Very good. Derek, thank you very much. We appreciate it. Thank you for being up so early this morning. You're a stalwart gentleman.
Well, thank you very much. All the presentations have been interesting to watch. Thank you.
Thank you. Joseph Gillings, you are in our same time zone, so at least you didn't have to get up too early in the morning, I hope. How are you doing?
Oh, just fine, thank you. Thanks for having me.
Joseph, you're a planner with the Port of Seattle, and obviously Puget Sound has challenges of its own. You've produced a report on how your climate adaptation strategy is working. Tell us what the port's thinking is.
Absolutely, thanks for having me. Will my slides be loaded, or should I do a screen share to grab the slides on this end?
Todd, do you have a presentation?
Yeah, I can bring it up if you want, or you can screen share, however you prefer.
Oh, in that case, I will screen share.
Okay.
So I'll have better control that way.
Yeah.
And do you have that?
We
Yes.
do.
Excellent. Okay, so my name's Joseph Gillings. I'm a senior planner at the Port of Seattle. We are happy to tell you about the framework we've come up with for looking at climate change adaptation, and specifically increased storm intensity and sea level rise. I'm a believer in generally having different ports learn from each other. But it's kind of interesting because while it's important to talk to each other, it always comes with caveats about varied local conditions. And so I've tried to, I'll be trying to call out some of those important regional differences that are pretty important to climate change and adaptation across different parts of the country. Just a little bit about the Port of Seattle. Now that we are in merged operations with Port of Tacoma for cargo, we are the 4th largest container gateway for the nation. And that joint operating agreement is known as the Northwest Seaport Alliance. We, similar to Derek from Hawaii, we have a range of lines of business. And so our cruise business and our commercial fishing business, not quite as big as cargo, but important to round out our business. So I thought I'd walk you through the way we contemplate climate change and what it means for us. And I'm going to take you from the abstract to the specific. In Washington State, our current economy has a lot to do with annual cycles of hydrology, and basically river flows and snowpack in the mountains, and how fast that snowpack comes out of the mountains. That has traditionally led to our heavy hydroelectric power reliance and frankly, the nation's lowest power rates. And then, of course, we have extensive agricultural exports. That's Washington's own agriculture, as well as some from further inland. That stands to be vulnerable in certain climate change scenarios. We also, at this point, want to note that you have to think about the resilience of the ports that are the ports of our trading partners worldwide. The reality is that our importance as a gateway is based on the manufacturing hubs in Asia. So still a little bit theoretical, but we have to be mindful that that their resiliency affects our resiliency. And so for the remainder of the presentation, I'll be elaborating on the primary mechanism of climate change that we feel like we can plan for at this time, and that's sea level rise and increased storm intensity. And I have some slides coming up that are going to break down the analytical approach to setting elevations. But suffice it to say that we're no stranger to the reality that shorelines are harsh environments, and our traditional paradigms all along for setting elevations have been based on worst case scenarios around storminess. This slide is just in here. I'm sure you've seen many like it. It's to contemplate planning and planning horizons. You know, the real takeaway is the further out the planning horizon, the greater the uncertainty is for sea level rise. So it's absolutely a good thing to be thinking about 100 years out or more. But you have to recognize that you've got a lot more certainty around the short range horizons like 50 years. And that's really where we focus for our planning. Another frame of reference for planning horizon is that 50-year would be the maximum asset life that we would assume when we undertake construction of a major asset. Won't dwell too much here. I'm sure you're all familiar with the different bodies out there making sea level rise projections. I'm sure we're looking at the same ones that you are. IPCC comes to mind right away, which is not actually shown here. What is shown here is that we have University of Washington in our backyard making Washington-specific projections. That brings in the vertical land movement component in Washington. But really the takeaway is that most of these credible projections have a fair amount of conformity to each other at, let's say, a 50-year horizon. So now I'm going to drill down on exactly what the analytical process is when we set elevations. What you see here is a illustration of how 3 Earth processes are additive for worst case scenario when it comes to flooding. Those 3 Earth processes are tide, storm surge, and sea level rise. Now, the only reason you have 3 bars here is to show the nuance that sea level rise is usually expressed as a range of elevations for the future. So each of the 3 bars shows all of the Earth processes. We're only tweaking the sea level rise between the bars. So what you have there, moving through the Earth processes, you have high tide, abbreviated as mean high water. Then you have a maximum tide showing periodic exceedance of that high water. Then jumping to the top, you have storm surge, which has actually never been more than 2 feet, according to our tide gauges, maintained for 100 years. So that's relatively small. And then you get finally to sea level rise. We're showing both a 2050 and a 2100. So this gives you the idea about how factors of safety that have been applied before talk of sea level rise are in the ballpark of the sea level rise that we're looking at for 2050. And so I'm going to elaborate on how the vulnerability really comes into play. But before I get to our actual flooding scenarios, here's this key reference to different parts of the country and what different conditions they have when it comes to coastal resiliency. What I've taken here is a comparison of major storm surge events in recent years, one for Puget Sound, one for Florida. And I probably don't have to tell you that tide ranges are very different, but this is just to illustrate how the specific role of storm surge. And so the little departure of storm surge that you find in the Puget Sound graph, you can see how small it is relative to the standard daily tidal range. But it raises the point. Imagine if, switch now to the Florida graph, imagine if tide were the only consideration, because you can see how dramatic the departure is from tide with the storm surge event they have there. The reason for that is quite simple, and that is that they have tropical storm systems throughout the Atlantic and Gulf capable of these very large storm surges. Okay, and now we move to our strategies and scenarios for our terminals here in Seattle. This is the first of 2 illustrations of a flooding mechanism. What's unique, both of these graphics come down to stormwater system design, because we believe that we'll be making major investments in stormwater systems before we're raising overall terminal elevations. And so this first stormwater illustration has to do with the fact that our terminals are unique for shoreline stormwater systems in that the elevations are pretty much dead flat. Hopefully they're high enough, but the point is that they're maintained dead flat for a distance of several hundred feet inland in many cases. So this leads to the issue of how fast can the stormwater system convey water from where it's entering the system to where it needs to be. And specifically, this is illustrating a condition we have on a couple of properties where grades even fall. They're mostly flat, but they do actually fall a bit towards the inland. Exaggerated a bit in the graphic for illustration purposes. But this is where tide valves come in, because we have to think about the possibility that water moves the opposite direction as intended and actually emerges inland. Here's the second scenario that is really motivating us. So we talked about the 3 earth processes: tide, storm surge, sea level rise. Now for stormwater performance, we have to add the fourth phenomenon of very intense precipitation event. And here we get to the fairly complicated matter of how readily the stormwater system can move water to off of the terminals. And this, the engineering term is hydraulic resistance. And it's laborious engineering work to literally calculate the friction of water moving through pipes. But it's already been shown that because of that hydraulic resistance, you can have water levels incrementally increasing as you move inland, as you can see at each of those inland control structures in the graphic. This has basically led to our, I think, most relevant strategy, which is to commit ourselves to modeling the performance of these stormwater systems whenever we undertake a alteration to the stormwater system or have a yard torn up for other improvements. Because we've already seen that incremental increase in water elevations can be 3 feet from the most waterward point to the most landward point on a terminal. So that commitment to modeling will point us to the most strategic improvements to boost the overall conveyance capacity of the system. And wrapping up here, stormwater conveyance is at the heart of our strategy. Electrical equipment is also pretty relevant for us. If you know anything about making electrical systems resilient, you know that there's always some redundancy, some belt and suspenders approach to keeping the equipment safe. And sometimes that's involved safeguards that allowed us to put electrical equipment at a low elevation. We will probably abandon that practice and have higher elevation as a key resiliency measure, rather than depending on electrical insulators for a lower installation. It's going to add a lot of cost, but we're ready to make that commitment. That covers the points I wanted to make. I'd be happy to hang out and take any questions that you might have.
Joseph, thank you very much for your presentation here. Arvind, do we have questions for our speaker?
No, we don't. We just have a schedule question from Brenda, which is
yeah, I answered that one. I told her California's next, but we'll be on in a few minutes.
No, I think one of the speakers has a hard stop at in half an hour. So
that was from Elaine Forbes. She had a hard stop. She's going to be listening. I'm
housing.
sorry?
Is it housing? David Housing?
No, I've already rescheduled. It's okay.
Okay.
Oh, okay, very good. Joseph, I want to thank you very much. This is an interesting concept which we haven't heard much of. And if you could send me, you've got my email, if you could send me a little background about how this hydraulic system is working, I'd be very interested in following up with you.
Absolutely.
Okay.
I'd be happy to do it.
Thank you very much. Joseph Gillings from the Port of Seattle. Thank you. Okay, we are on to the California delegation or panel, and our first speaker is Lieutenant Colonel John Cunningham, who is the San Francisco District Commander for the U.S. Army Corps of Engineers. He'll be followed by Brad Benson at the Port of San Francisco, Jan Novak at Port of Oakland, Brenda Gaydon at the Bay Conservation and Development Commission, and David Halsing from the South Bay Salt Pond Restoration Project. Colonel Cunningham, are you here?
I see that he's in the audience. I wonder if Todd, you can move him to the panel? I see his name there on the audience.
Todd, while you're doing that, because we've got a time issue, I'm going to ask Brad to come up, and then we'll have the Colonel come in next, okay? So Brad Benson, Port of San Francisco. Elaine Forbes alluded to some of the challenges that you have with the seawall. You and I have been discussing this for the best part of 6 months. You were the first person I talked to about this conference, and because you said it was a good idea, we decided to go ahead. Brad, thank you very much for being here. You have a new study about your seawall and the issues related to liquefaction in the downtown area. Tell us about it.
Excellent. Thank you, Stas. Thank you, everybody who worked to organize the conference today. Let me share my screen. Can everybody see that?
Yes.
Okay. Full screen. So I'm Brad Benson, the Port's Waterfront Resilience Director, here on behalf of Executive Director Elaine Forbes. We've got two issues, as Stas referred to, that we're dealing with along the San Francisco waterfront. We've got a very urgent, sort of nearer term seismic risk exposure, and we have a longer term sea level rise challenge, although we do have some current flooding today. So I'm going to go over both of those, and very happy that Lieutenant John Cunningham is here from the Army Corps. We're partnering with the San Francisco District on a flood resiliency study of the waterfront, and I'll be going over that a bit too. So the port manages 7.5 miles of San Francisco Bay waterfront. Under trust for the people of California, we operate maritime terminals in the southern waterfront. We have a lot of harbor services up in the northern waterfront. Northern California's fishing fleet calls the port home. But we're unique among many ports anyway, in that the city comes right up against the port. So in the northern waterfront area, we have downtown San Francisco right across the street. So it's a very diverse waterfront, unique activities in different areas of the waterfront, and a pretty limited adaptation zone through most of the port property. The port's jurisdiction is shown in yellow here. So the resilience program has a number of activities that are port-wide. The flood resiliency study with the Army Corps is the entire 7.5 miles of port jurisdiction. We have other efforts that are more geographically focused. The Embarcadero Seawall program is from Fisherman's Wharf on the left-hand side of the slide to Mission Creek, the middle creek that you see here. So about 3 miles of the waterfront. And there is significant overlap between these efforts. So the Army Corps flood study overlaps that Embarcadero Seawall area. In the Embarcadero Seawall program, we're dealing with both seismic and flood risks. The flood study is focused on flooding, to the extent that it yields a federal project that will be designed to seismic codes, but it's really not focused on the seismic risk that we're handling along the waterfront. This is some of the flooding that we experience today in the ferry building area. We can have 1 or 2 lanes closed in certain king tide and storm events today. This is mainly a worry because not too far south from this area, we have the Embarcadero Muni system coming from underground to above ground. And there is a flood risk exposure to that Muni tunnel, and that Muni line is right above the BART tube. So that's the regional transportation system in the Bay Area. So just to go over the flood study, we've been seeking collaboration with the Army Corps since 2012. There was a narrower CAP study that found that there was a likely federal interest. We're now in what we think will actually be a 6-year study, probably costing $20 million with a 50-50 cost share. We were lucky to get one of these two, general investigations in 2018. We're looking at 5 sea level rise curves, the 3 Army Corps curves, and 2 State of California curves. The study period is from 2040 through 2090. It's a very rigorous study. We're pursuing robust community input. If we determine that there is a federal interest in the project, of course, the Army Corps would pay 65%. We would match it 35%, and the Army Corps would deliver the project. So in the Embarcadero Seawall program, we've just published something called our multi-hazard risk assessment, looking at seismic and flood risks. This is independent of the Army Corps work. We did a 2.5-year very detailed risk assessment. We looked at a range of different seismic events, 4 different seismic events, including a 1906 type of earthquake, a range of flooding scenarios, including different sea level rise curves, looking at impacts not just to the port, but to city infrastructure. And the Embarcadero roadway along our waterfront is full of city infrastructure, including important wastewater infrastructure. We did geotechnical analysis. We really examined the shoreline and wave action along the shoreline. It's a very robust study. We identified up to, on a probabilistic basis, up to $30 billion in cost of damages and disruption by 2100. We've identified different levels of seismic risk in different areas of the waterfront. In the ferry building area, that is the former Yerba Buena Cove. You can see where the cove was by the extent of flooding here. Essentially, under certain sea level rise scenarios, we give back the land that was reclaimed to make downtown San Francisco. Because it is the former Yerba Buena Cove, they're very deep young made mud in that area, and we have bigger seismic risk. And then we also have piers and wharves along this entire stretch, and we've got a very vulnerable wharf zone in terms of lateral spreading. And then as I'll talk about a bit more, it's a very flat waterfront and flat downtown. We have a significant flood risk tipping point between 2 and 3 feet of sea level rise. So I've talked about the Embarcadero roadway. It's got weak soils under it. We're concerned about the performance of the roadway in a relatively foreseeable earthquake. We could have significant utility damages. And then you're probably familiar with Fisherman's Wharf. We're quite concerned about the performance of the wharf. Most of the structures were built there in the 50s and 60s before the advent of seismic code. So we have a lot of timber pile supported structures in that area that we're concerned about. So this is sort of a cross section of our shoreline. When the port was initially built, the idea was building this seawall out to deep bay water. They trenched. The dike is about 100 feet wide at its base, about 40 feet tall. They put fill, albeit unengineered fill, behind the seawall, and they created wharves that were supported by piles driven through the seawall. In the areas where this exists, the wharves are flood protection for the city today. This is what we're concerned about in a very large earthquake, a 1906 or greater earthquake. We would have liquefaction of the soils. It's on a slope that would push bayward, driving the seawall bayward, creating fractured piles and potential collapse risk. And it's not a theoretical concern. The photo on the bottom right is the Embarcadero in the 1906 earthquake. This is near our Pier 27, and the soil conditions have not changed. So I talked about that 2 to 3 foot tipping point. The waterfront was designed 100 years ago at a certain level. It's functioned pretty well over that 100 years. We've had about 9 inches of sea level rise. Some areas, like the ferry building area, have subsided a bit. And you see on a king tide today, we're running out of freeboard. And with 2 to 3 feet of sea level rise and a significant storm event, we'd have overtopping of these wharves. And I was really interested to hear about the example in Hawaii where they're thinking about what to do with their pile supported piers. We're struggling with many of those same issues. So I mentioned earlier, we're looking at 5 sea level rise scenarios, all of the Army Corps curves plus 2 state curves. You know, as we think about sea level rise, we do think about those different water levels, mean high water, the 100-year flood, you know, and how all of those levels are going to increase over time with the different sea level rise scenarios, including we have a very porous shoreline. So we see the problem with groundwater rise with sea level rise. And that could, with that 2 to 3 feet, really big impact on utility infrastructure behind the seawall, behind the shoreline. So we've been hard at work, not just analyzing the problem, but beginning to think about the various measures that we could build in order to minimize these risks. I'm going to go over this pretty quickly. So for the seismic risk exposure, what you see across the top are representations of the strategies that we've been analyzing. There to really stabilize the shoreline, we'd either have to do a new bayward seawall, bayward of the existing one, and create new land, do a landside buttress, similar kind of strategy, but in Embarcadero roadway. We've been looking at very large drilled shafts to provide shoreline stability. In shallower areas, we could do something called what we call a super bulkhead wharf to pin the seawall in place. We're also looking at more targeted measures that won't stop lateral spreading, but could provide for like safety and structures adjacent to the shoreline. So we're costing these things, looking at construction impacts, ability, adaptation right now. And then with the help of the Army Corps, and we're so happy to have them as a partner, we've been looking at all the different types of flood risk reduction measures that could be deployed, both physical, you know, typical like seawalls, levees, breakwaters, and ecological. And we're really happy that the Army Corps, you know, is interested in those ecological measures as well. We have some opportunities for those in the northern waterfront. It's a man-made waterfront and it's a steep drop-off, so it's very hard to create habitat in that environment. But we're going to try. In our southern waterfront, we have a little bit more room for these measures. And then where are we? You know, we've done a lot of risk analysis. We've developed these measures. We've been talking with the public all the way along, including our city department partners. We're taking all of that information, and then with the help of the Army Corps, we're formulating a range of alternatives so that we can present those alternatives to policymakers. And we're developing a decision-making, you know, approach, including evaluation criteria and funding guidelines. And we're driving towards first projects that would be identified in early 2021. We're lucky to have a general obligation bond approved by voters in the amount of $425 million to fund those first projects. So I will just end here. In the Army Corps study, that's a little bit of a longer term analysis. We're doing what's called a future without project analysis. It's a very complicated modeling efforts looking at all public and private assets in the future floodplain to determine the potential benefits of a federal investment. We're going to continue to iterate alternatives waterfront wide to minimize those flood risks and to see if we have a federal interest. And we're engaging policymakers in the options for shoreline protection along the Bay waterfront. And so I will end there. Thank you so much for having us.
Brad, thank you very much. We appreciate that.
Okay.
Our next speaker is Lieutenant Colonel John Cunningham. Good morning, Colonel.
Hey, good morning, or we may have broken over into the afternoon now, Stas. So,
I think we did.
thanks for, what a fantastic couple days worth of discussion, and really excited to be a part of it here. And really perfect timing to follow Brad, and we couldn't be more grateful for the partnership. looking at some of the real issues in a very constrained and important area of the San Francisco waterfront. So thank you for including us today.
Thank you. So,
Well, yeah, go ahead, Stas, please.
no, the floor is yours, Colonel.
Yeah, thank you. Sorry, I jumped in. I'm just so excited to get into this topic. You know, as Brad mentioned, and all of the speakers I think have indicated, these are some really challenging and complex topics, but the impacts are huge. The benefits, if we look at it from that perspective of addressing this early and effectively, are also huge. And I think where we find ourselves as a federal agency, and I think all our state, local, private industry partners, we see a requirement for us. There's no way to address this single-handedly. We got to have an integrated approach, and we need to look at some innovative and some flexible ways to deal with this. So the topic, I think, for the panel and where I'll go with this is, you know, the dredging and seawall and beneficial use, I think, are some areas I touch on. I think I can tie them all together back to the sea level, the coastal storm risk, and the way we might be able to get after addressing sea level rise around the bay and along the California coast. And I'll maybe pivot off and I'll get back to the San Francisco waterfront study. But first, I'd like to talk about, you know, the operations and maintenance dredging as a program that we manage. So the federal government maintains the 22, you know, federal channels that our district specifically manages, including Port of Oakland and a lot of smaller coastline ports along the Northern California coast. But those channels, like the main ship channel into the San Francisco Bay, are incredibly important economic and, you know, recreational and transportation highways that we just absolutely need to maintain. It really, especially with the coronavirus and the impacts on the economy, we've got to continue to look for ways to make that system more resilient and resilient into the future, including, you know, adapting, you know, as Port of Long Beach mentioned, and, you know, New York, how do we adapt as the sea changes? We want that system to be able to respond. We're trying to posture our program in order, you know, to address the next, maybe the nearer term, you know, period of time, this 20-year look ahead, using a regional dredge material management plan. That's a construct that the Corps uses to, where do we dispose of, you know, what are some of the economics associated with the individual ports or channels, and then how do we dispose of that material? What are the sites? What are the means and methods? You know, how do we strategically want to address that? And rather than do it on a project by project basis, and we're trying to wrap all of these Bay Area channels into one dredge material management effort. So it's a programmatic look. What that allows us to do is maybe find some efficiencies and look at ways that we can complement, you know, the efforts we're doing in one project with the other, and hopefully be able to turn that into some better opportunities for beneficial reuse for, you know, nature-based coastal storm risk projects, or, you know, some of the levee construction projects potentially, or things that the community is doing. So that's an important effort that's really just kicking off. It'll probably take us, you know, 3, 4, 5 years to get it right. And we're not in a hurry, but we appreciate all the collaboration up to this point as we've built a project management plan. And that is in what I would say is probably final draft form right now. We'll continue to push that out to get feedback on, do we have it scoped correctly? We're interested in, you know, partnerships on science, making sure we can, you know, using some of the funding we provide, you know, get after some of the questions, you know, whether that's sediment transport or whether that's, you know, some of the impacts we might have on species, or how to more effectively dispose of material. We're trying to get a good understanding of the problem, I guess, as part of this initial part of the dredge material management process. So the other thing is that program is very consistently funded by Congress and the administration. And so as a result of that, we remove about 1.5 million cubic yards annually from around the Bay. It's a really valuable resource, and we recognize that. What we need to do, I think, is part of that process is how do we more effectively do that? And we do a fair amount of upland disposal, but a lot of it goes either in bay, you know, in one form or another, or it goes to the ocean for deep ocean disposal. And I know you'll probably hear from BCDC and Ms. Gaden in a little bit, you know, some of the ideas. And I think we're trying to collaborate, look for opportunities where we can tie other projects and other funding streams in order to allow us to better use that material. And it, again, we all have constraints in terms of policies and, you know, procedures and processes and authorities. And so the better we can work together to find opportunities for, you know, collaboration to fund the incremental cost to go upland, or to go to find some of the innovative authorities out there. We've got a authority out there that allows us to go try a pilot for nearshore placement. And so we're excited to continue to step into that. It's a smaller effort, but allow us to try and you know, dispose of some material near shore and hopefully feed into some wetlands near the shore. I think that if we can crack the code on those smaller efforts, I think that's going to open up the playbook for some of the larger coastal infrastructure projects in the near future. One of the challenges I would just share on the dredging program in general is the funding process doesn't nest well with the need and the year of execution. And what I mean by that is we're generally working 3 budgets. We're developing one, we're defending another, and we're executing you know, the current year budget. And so that 2-year ahead look is really challenging to align the amount of sediment that we think we'll have in that year with the reality of what actually shoals in that year. And then sometimes there are opportunities that present themselves inside that year of execution or right before we start dredging that would be really, really great to take advantage of, but we often don't have the flexibility or the I guess the word I'd be looking for is the nimbleness in our process to be able to take advantage. And I'd use Petaluma dredging as an example of that, where we this year we were very excited to have been funded for the Petaluma Channel, and we're finishing up dredging across the flats now. But there was a small window where we realized that there might be some opportunity to dispose of that material upland. And, you know, as we planned that out several years prior to that, you know, we just hadn't built the flexibility in when we were working with our partners to get the disposal location. And so it was a good lesson that we learned this year. And we're certainly looking for ways that we can incorporate that flexibility and those options into our process. I think that's going to help us in the future where, you know, say one of the local communities has a, you know, a levee or a shoreline project that would help you know, using nature-based solutions. There may be some opportunities as we dredge to pump ashore or to do some nearshore placement. So I guess the underlying question in that first, you know, the dredging is how can we find efficiencies? How can we find flexibilities, opportunities to collaborate? And we're certainly committed to that. And they're going to be challenging. It's going to take a lot of energy. And I think history has shown that those are difficult. But when they play out, you know, say like the Hamilton wetlands restoration, it can be an amazing outcome. So I think that's great to continue to look out for those. We do have a number of projects that are addressing coastal storm risk right now in various phases. You know, Brad Benson gave and Ms. Forbes from the Port of San Francisco gave a great overview of the efforts with the Port of San Francisco waterfront. But I think what those highlight is the projects that are going to address sea level rise are going to be exceptionally difficult and are going to take a lot of different stakeholders and partners to execute well. There's a diversity of perspective and there's a diversity of authorities and funding streams that'll be required for each of the individual localities. And I think each location is going to present its own you know, challenges and require its own solutions. Our shoreline project down in the South San Francisco Bay around the community of Alviso in partnership with Valley Water is a fantastic project with broad consensus and support. But the costs and coordination associated with that, you know, levee construction, more traditional, you know, levee construction type project that have shown us that, you know, material delivery and, you know, real estate acquisition and, you know, environmental permitting are all, pretty well established in, routine processes. But when you try and pull all of those things together in the area in which we work around the Bay, it is proving difficult to deliver these projects, on budget and in schedule. And so we're really looking to find better ways to get costs under control, I would just say, and look for ways that we can collaborate so we can get some strategic long-term wins, with a little bit of, on all of our parts as project partners, some compromise from each of us. And so I think you'll find that with any of these projects, because there are just a number of competing interests. And then agency, public involvement, environmental compliance, and the technical solutions. All of those things, again, they're going to require a lot of integration, a lot of energy to pull together the various levels of jurisdictions and the decision makers and the funding streams. I think the solution similar, Brad's one of his last slides that showed the various alternatives we're examining for the San Francisco waterfront is a fantastic way to highlight just the different solutions, and each of those has different benefits and different, pros and cons. And I think we're going to have to look holistically at these projects, and we're going to have to look at the specifics too. We're going to have to look at the areas where those solutions apply, and be open to both gray infrastructure and green infrastructure. And by that, I mean nature-based solutions for hardening, wetlands restoration. I love the way Elaine framed it, Ms. Forbes framed it from the port, is adding nature back to the Bay. I think there are some cases where, that can make us more resilient to the groundwater and flood factors associated with sea level rise. And so, again, comprehensive solutions, no one size fits all approaches are going to work for this. And so we're going to need to involve the public, the private, the state, local, and federal partners to get this done. And I think that's going to take a lot of work to align our authorities and some new, potentially new policy and legislative solutions. But we're certainly committed to solving these problems together. And anyway, so I'd love to continue the discussion here. And thanks again for the opportunity to talk.
Colonel, thank you very much. You did a really good job of covering a lot of ground, and you didn't use a single slide. So thank you very much for this. Arvin, okay, we're holding on the questions. I had one question, but we've got to get our other guys through here first. Our next speaker is Jan Novak, Port of Oakland. He's the Associate Environmental Planner and Scientist. And Jan, you were with us last year. Welcome back again.
Thank you very much, Stas. Glad to be here. As Stas said, I'm Jan Novak from the Port of Oakland. We're a department of the City of Oakland. The City of Oakland is colloquially known as the town. Here's a view from the Port of Oakland. You can see the beautiful city of San Francisco across the San Francisco Bay from us. And also, thank you, Stas, for putting this together. And I just also wanted to say it's an honor to be able to follow up after the Colonel. There's a saying, I didn't make it up, that if you've seen one port, you've seen one port. Each port has its own unique identity. What makes the Port of Oakland unique is that we are both a maritime port, which you see here over on the left side of your screen in purple. We're a container port primarily, and we have about 50% import and about 50% export. We're a good access way for the Central Valley of California, which is really a breadbasket of the United States, to export fruits, vegetables, wine, and proteins to the Asian market. And we also have the Oakland Airport, which you see in blue over on the right. So we manage both of those. As with other California ports who have been granted tideland from the state, we were asked to perform a sea level rise adaptation strategy assessment, which we completed in June of 2019 in pre-COVID times. So I'm just going to run you through this real quickly. We did an inventory of all our assets. We looked at inundation levels for 2030, 2050, and 2100 based on the same 2018 State of California data that Mr. Benson at the Port of San Francisco used. We did an assessment of our vulnerabilities. So that's the overlay of our inventory with the sea level rise mapping. We were able to figure out what our financial costs to sea level rise would be and start developing adaptation strategies. I'd say that the study for us was the first stepping stone, and it's really gotten the ball rolling at the Port of Oakland. As some of our Dutch colleagues were mentioning earlier, most of the human psyche, we work best after we've gone through some sort of trauma, and the Port of Oakland up to now has avoided major flooding impacts. So perhaps we're not as far along as some of our colleagues in the Texas area and the New Orleans area. But here, if you look at these figures, what I wanted to highlight, so that the areas that are shaded is land that's not owned by the Port of Oakland, and the pink is the flooding from a 100-year storm plus sea level rise. What you can see is that a lot of the flooding for the 2030 and 2050 maps comes in from our neighbors. And so one of our biggest takeaways from the study is that we will, in order to really address sea level rise, we'll need a bay-wide approach to sea level rise. If we at the port were to fortify all of our structures, we would literally just be passing the problem on to the rest of the San Francisco Bay Area. So Ms. Gaden will be talking in a bit, and BCDC has been on the forefront of leading a bay-wide strategy for sea level rise, but we still have a ways to go. Two different fronts. On the one hand, we're trying to fortify and make our structures more resilient, but we also wish to reduce our emissions. So we've come up with a 2020 and beyond plan, which is our plan for getting to zero emissions of all port facilities by 2050. This is like I said, our pathway to zero emissions. It's incremental, and right now our biggest success is that we use shore power, which I'll show you on the next slide. So shore power is when ships come into port, when they call it the Port of Oakland, they're able to plug into our electrical grid, thus being able to turn off their diesel engines. So as a result of that, we've been able to greatly reduce particulate matter and emissions in the area. We've also worked with our independent owner-operators of our drayage trucks to get their engines modernized. So we've, over the last 20 years, reduced diesel particulate matter by over 90% in the West Oakland area. Currently, we're working on bringing in hybrid rubber-tired gantry cranes. We've got 4 of those, and we're trying to bring in as much hybrid equipment as possible. And as the electric equipment becomes more sophisticated and able to handle longer days, we'll be bringing in more electrical equipment as well. Just wanted to, on the more theoretical side or the more experimental side, we're working with the California College of the Arts. They have created a prototype breakwater called the Float Lab, which we put in our Middle Harbor Shoreline Park. The Float Lab, you can see here in the drawing on the right, has multiple uses. One of them is to serve as a wave attenuator, so to reduce the erosive force of the waves before they reach the shoreline, but it also creates habitat below the water for invertebrates and also fish and other species. So that's a prototype. We look forward to working with them more in the future. And lastly, going back to what the Colonel said about opportunities to utilize sediment material for beneficial reuse projects, what he referred to as upland. We have a turning basin project that we are just initiating we are going to be widening or plan to widen our turning basins to allow for larger cargo ships to call the Port of Oakland. And as a result of this, we'll most likely have millions of cubic yards of sediment that could potentially go to beneficial reuse. And we look forward to collaborating with our federal partner, the Army Corps, and also with the regional agencies in moving this project forward successfully and hopefully getting that material to beneficial reuse. So I'd like to thank you for your time. I hope you enjoyed learning about the Port of Oakland. And again, thank you to Stas and the Propeller Club for putting this together. It's quite a change from 2019 when we were in person and live in Oakland. And thank you for adapting. You've shown resilience in your agency. And thank you to the Colonel and to the Army Corps for all they do for the Port of Oakland.
Jan, thank you very much. And I reinforce our plug for the turning basin for all of the good reasons that you mentioned for the Port of Oakland, which we all support.
Great, thank you.
Our next speaker is Brenda Gayden, Sediment Program Manager for the Bay Conservation and Development Commission. Good afternoon, Brenda.
Good afternoon, Stas. I am sharing my screen, so let me know when you all can see it.
We can see it.
Great. Okay, so thank you for having me today. My job, as given by Stas, was to throw out some ideas and maybe move the needle on beneficial reuse. So all of our speakers in today's panel have talked a bit about the need for sediment in one way or another to adapt to sea level rise or to provide habitat benefits, etc. So I'm my presentation is more of a thought presentation versus a project presentation, but definitely relates to all of the great talks that have been given today. So as Stas said, my name is Brenda Gayden. I'm the Sediment Program Manager from San Francisco Bay Conservation and Development Commission. So just a little bit of context for folks who are not from the Bay Area. 20 years ago, the LTMS agencies developed the LTMS program with consensus from the dredging community and the environmental and fishing community. We developed 4 goals, which are on the screen today. But the main point of the LTMS program is simply to maximize beneficial reuse of dredge sediment and minimize in-bay disposal. We used the deep ocean disposal site. Initially, the plan was as a stopgap measure, although unfortunately it's been used a bit more than we had anticipated over time. By the numbers, over the past 20 years of the implementation of the LTMS program, nearly 65 million cubic yards of sediment has been dredged from San Francisco Bay. About 26 million were disposed of at in-bay disposal sites. Another 13 million went to the deep ocean disposal site, and 28 million was beneficially reused at various sites around the bay. On average, we dispose of about 1.3 million cubic yards at in-bay disposal sites, and about 0.7 goes to the ocean, and 1.4 million goes to beneficial reuse. I put up the red box here because I look at the red box and think, is there some way we can move the needle, as Stas put it, in getting this material also to beneficial reuse? So that represents another 2 million cubic yards of potential sediment for different options. So the origin of the program for LTMS was an environmental crisis where we couldn't get dredging done, and the environmental community had no faith in the cleanliness of the dredge material or the effects to the environment on dredge material. That's where we started 20 years ago and resolved that crisis with the LTMS program. However, 20 years in the future, we have another set of challenges which the LTMS can help with. Sea level is rising and sediment is declining. I'm not putting up a slide on that. I think many speakers have talked about sea level rise. The opportunities that I'm going to talk about today for these challenges are federal policies, cooperation and coordination across the region, which is something the Bay Area is known for. So most of folks who work in dredging programs with the Army Corps of Engineers are familiar with the federal standard. It is known as the least cost, environmentally acceptable with standards for engineering policy. And unfortunately, this policy has been a bit of a frustration in getting material to beneficial reuse. And one of the thoughts that I've often thought about is the Army Corps has 3 missions. It has flood protection, environmental systems services, and navigation. What if we were to break down the silos of these 3 business lines and look for areas where we have beneficial reuse or beneficial aspects of a project that meets all 3 business lines? So rather than environmentally acceptable, what is the environmentally beneficial project? Flood protection can address sea level rise, ecosystem services can address endangered species, as well as helping with flood protection, and navigation can supply that material. If we were to do that, we would have about 2 million cubic yards of sediment from San Francisco Bay's federal navigation projects that we could use. That's not to say the Army Corps has not beneficially reused material. They have beneficially reused quite a bit on a regular basis. My point is that there is possibility to do more. And a different federal agency, the Gulf of the Fairlands National Marine Sanctuary, which is shown on the right, there are some actions taking place. This is outside of my jurisdiction, so I don't have a lot of information about it, but I do know that they are working hard to consider changes to their regulations. And one of the changes they're looking at is permitting beneficial reuse of sediment along the coast in the sanctuary, as long as the material is clean, from 4 harbors that are within the sanctuary's boundaries. Switching to cooperation and coordination, we have an opportunity in the San Francisco region to increase cooperation and coordination of the 5 ports, perhaps by developing a port authority or other mechanism that could result in dredging schedules that maximize equipment use, making more efficient use of the equipment that could target specific beneficial reuse sites, restore habitat, and green infrastructure more quickly. And this approach could play into the different ports' climate and green action initiatives. Targeting specific restoration projects for beneficial reuse could help us reach resiliency goals more quickly, and could be approached by picking a site or a period for concentrated reuse, focusing on planning activities of dredging and targeted restoration projects, ensuring that equipment is ready, volume thresholds are met, and we can work with contractors to meet the investment that they need to reach those volume thresholds. This is similar to the model that the Hamilton Wetlands Restoration Project took, that took 5.6 million cubic yards of sediment to one site in 7 years. One of the challenges that we would see in projects that use that amount of dredge material is water management. Of course, the ever challenging funding issue and potentially queuing of equipment on the dredging side. Lastly, we could also consider a regional sediment management approach, which is another policy that a different group of the Army Corps of Engineers has. But looking at regional sediment management, we're looking at efficiencies and synergies for projects across the region. And the Colonel spoke of efficiencies quite often, which I totally agree with his approach. In this case, I have a map on the screen that shows where we could look at efficiencies across different sectors. So this is a central marin site where we have a flood control channel shown in this dashed line. We have a a ferry terminal dredging channel. We have several restoration sites, and not shown on this map because it's not yet developed. We have a local community that needs some sea level rise enhancements that would involve sediment or soil placement. So coordinating and cooperating across sectors such as this could provide benefits to the community, benefits to habitat, and efficiencies, and hopefully some savings as well. but that would be yet to be seen because we haven't looked at that kind of cooperation and coordination across a section of the bay at this point, perhaps to come in the future. With that, I conclude my talk, and I thank you for your attention. And Stas, I hope I stayed within my 7 minutes.
You're a champ, Brenda. I am very impressed. In fact, you're probably the only person who did that today.
Well, that's my charge. Thank you so much for having me, everyone.
Brenda, this was really a very inspiring presentation because you've given us a nature-based strategy to move forward with. And we'll make some comments right at the end. David Halsing, you are at the ground zero of just the kind of beneficial use that we're looking for, and we're not able to use dredge material from from harbor dredging projects to get your project going. You are the executive project manager of the South Bay Salt Pond Restoration Project. And what do we need to do to get this dredge material into areas like your salt pond?
Well, thanks, Stas. I'm going to get things set up here and rolling. It's an honor to follow such esteemed colleagues the way I am doing. It's great to be the last speaker in a 2-day conference. Everybody likes that, right? So I'm Dave Halsing. This is I'm going to stay with the time. What's that?
Last but not least.
Last but not least. Well, maybe. I do have some pictures of wildlife, and I might be one of the few to do that. Yeah, I'm Dave Halsing. I manage the South Bay Salt Pond Restoration Project. The place where my project and this conference overlap is in the potential for beneficial reuse of dredge material. And I'm going to focus on that. But first, I need to back up and just tell you a little bit about our project, what we're doing, why, and where, so that you understand kind of what we mean. This is a large multi-phase, multi-decadal project. It's over 15,000 acres of former industrial salt production ponds that were acquired in 2003. We have 3 goals. The first is to create habitat, primarily tidal marsh, by opening the former salt production ponds to tidal flows, accreting sediment, and then when it reaches the right elevation, marsh plain, primarily pickleweed, but other plant species as well, will establish and grow, and that provides tidal marsh habitat. We also work with the local flood protection districts and state and local state and federal agencies, excuse me, to do flood protection. We need to maintain or improve current levels of flood protection along the shore of San Francisco Bay. And our third goal is to add public access and recreation. We really want to bring people into contact with the bay and the sloughs and the waterways around it. So we do a lot of trails and interpretive features, viewing platforms. There's even a kayak launch. So these are our project sites. I'm just going to point out kind of where things are. Everything in blue here is about 5,000 acres. This is now part of a state ecological reserve called Eden Landing. It is managed by the California Department of Fish and Wildlife. Everything in green, these 2 large areas in green, are part of the Don Edwards San Francisco Bay National Wildlife Refuge. So those are federal lands. Everything in the gold is still in production by Cargill, and this red area is actually still owned by Cargill. So they're still making salt there. What's good on this slide is that you see all these little sort of segments, these little cells. These are the ponds. These are the berms that were separated out to evaporate water and gradually concentrate it and harvest the salt. And that's really important because what we're talking about is opening up these ponds and bringing the bay in. And we've done that quite successfully. In phase 1 of the project, we established 3,000 acres of marsh and 700 acres of some ponds that we kept as ponds, but enhanced them for the kinds of birds that like to nest on islands inside of these ponds. We can talk about these things later if you like, if we have time. We also added 7 miles of trail, including some portions of the Bay Trail spine, several viewing platforms, and a kayak launch. So that took about 7 years to do those. And since 2012, we've been working on the design, the planning, the NEPA, CEQA, permitting for phase 2 which is under construction now. So we have 5 different areas that we're working on in phase 2. 4 of them are in the refuge, and the 5th and much larger one is the entire southern half of Eden Landing. And this is really what I want to focus on here, because it's where the dredge material comes in. So this is the southern half of Eden Landing, and we're doing actually 3 different types of habitat restoration here. I'm not going to go into 2 of those because they're not directly relevant to what we're talking about. These inland ponds and these southern ponds over here are going to get muted tidal or enhanced as managed ponds. But what we really want to focus on today is these 4 large ponds out here next to San Francisco Bay. And you know, these ponds are about 2,000 acres together. Maybe less than that, about 1,500 acres together. And they're about the bottoms of these ponds are about a foot or 2 below the elevation that marsh would start to form. So if we breach these ponds now and expose them to tidal flows, they have to accrete a foot or 2 of sediment before they can start to form marsh. And that's going to take some period of time. It depends on sediment concentration. It depends on sea level rise. It depends on accretion rates and, you know, a number of different things. So what we wanted to look at to try to speed that up was whether or not we could accept dredge material here. And that's what this little feature is. This is the slurry pipe that we sort of postulated for the purpose of the environmental permitting or planning documents. The idea there was that somebody would build an offloader out here at the edge of the deep water channel in San Francisco Bay, and we'd set up an intake system and slurry pipes and some booster pumps, and we deliver that material to the interior of these ponds. And you know, that actually could take something like 4 million cubic yards over a few years if it were available. So everybody seemed like they were very interested in that. The problem is this is about a 3 or 4 mile run here. It's quite a long way. And so it turns out it's pretty difficult to do that. The idea behind the reuse of dredge was that you know, if we got it in advance, we could take 4 or 5 million cubic yards and raise the bottom of those ponds so that when we breached it, it would form marsh that much faster. The problem is, without a couple of large capital improvement projects such as the turning basin that Jan described, you know, it could take 4 to 7 years just to deliver that material, and that would extend the construction period to out near a decade. So, you know, we'd have higher pond bottoms to start, which is good, and we'd increase the certainty or the chances, I guess, of keeping up with sea level rise. So that's good, but we lose that time wherein we might be accreting material naturally if we breach sooner. And all modeling and available evidence indicates that we think we would establish marsh before the projected sea level rise rates really ramp up in a couple of decades. So it wasn't really a necessity, it was more like a bonus. We were still open to it, we still wanted to do it, but there was a very detailed cost analysis and sort of bid strategy laid out for it by the firm Moffett and Nickel, and their cost started at something like $165 million, and that's between the offloader and the booster pumps and the power line to run power out there to run the pumps, and all the labor and the time and everything involved in that. Now, the rest of our project is estimated to cost about $25 or $30 million. And that's a lot of earthwork and a lot of water control structures and trails and fences and lots of other work. And so it didn't really pencil out for us, right? We probably save a little time, but maybe not that much. And further, no one has yet stepped up and said, yes, we think that's a great idea. We'll buy that offloader and deliver that material to you. And so we're backing away from it now. But what I wanted to indicate was that there are still opportunities for partnerships, kinds of like what Brenda was just talking about. You know, I've sort of focused on these ideas of public-private partnerships where, you know, that something like ports and dredgers and the shipping industry and the regulators and all of the different restoration projects, state agencies, everybody chipping in and sort of sharing this. Sharing this this infrastructure, making this investment up front that could maybe reduce the risk and bring the break-even time in. It's probably too late for that at Eden Landing, but other places exist. This is an ongoing need in the Bay. And so that's where we are. And I was a tick over my 7.5 minutes, Stas, but it was close.
You are very, both of you, you and Brenda, I tell you, you get gold stars. If we had any prizes, you two would get it. Thank you very much. Dave, this is a critical question. I think Brenda gave us the strategy and you gave us what the tactical situation looks like on the ground. And it's very clear that we need to move forward with a nature-based strategy because it's the environmentally best way to go. We don't want this dredge material being dumped into the Pacific Ocean when it can be helping us in the bay. So the question is, how do we get from here to there? And that is a question that is not easily answered, but I'm going to ask you, since you were the last speaker, based on what you saw, you and I have talked a little bit about the issue of coordination. Brenda talked about the issue of coordination. The ports are the critical path in this coordination. How can the ports help you get across the street on this issue of nature-based solutions?
You're directing that to me? Out of all of these, out of all of these port people. You know, I mean, cost share is an important part of everything, right? This is almost like a public good. If we think of the offloader and the delivery system and operating that and making it work, if you think of it as a public good, it's not in any single party's interest to do it, right? But if it's done by everyone, everyone can benefit from it. And so if you think about it that way and sort of recast it, then it's something we need to make a shared investment in. And now, how to do that? Well, there's an awful lot of private sector entities and entity types that could benefit from something like this, right? And so there's some interest there, but there's also a lot of public agencies, flood management agencies and wildlife management agencies. So that argues, in my mind, for a public-private partnership. And the terms of that are challenging to work out, but I have a sort of an intuition and a logical position that that's probably part of the answer. And I don't know how much Brenda or others on this call have thought about it, or Colonel Cunningham, but I feel like that's probably the way we should be looking.
So I'm going to put Jan Novak on the spot. Sure. Because Jan, you know, you're the man on this one. How do you where do you figure? How do you think the port could go on this, and how can the ports play a greater role?
Well, I think, Stas, you know, I've been at the port for about 3 years. I'm working on the last piece of the minus 50-foot project, which is the Middle Harbor Enhancement Area. I'm working with Brenda on that. And I've talked to a lot of people who've been involved in that process. You know, out of the minus 50-foot project, we got Hamilton Air Force Base, we got Middle Harbor Enhancement Area, and we also got Montezuma wetlands restoration sites. So we got 3 restoration sites out of that project. Almost all the material from the port ended up going to beneficial reuse. And it seems like there were a lot of different pieces that had to be activated. You had support from Congress people, you had a lot of political support, you had a private entity in the form of the Montezuma wetlands that got formed, you had agency collaboration and coordination, and those are all really big pieces. And it was a challenging project, and frankly, it's not quite done yet. And not, unfortunately, you know, not all the pieces worked out exactly the way people wanted them to. You know, some of the sediment that we were hoping would go to Hamilton ended up in the Middle Harbor and vice versa. But overall, I think the project was a success for the Bay Area. We got 3 significant restoration sites out of it. So I think it's going to take something of that level. We're going to need, I think Brenda has a great idea of how to get more material into beneficial reuse, but right now all the agencies and you know have their own constraints, and you need kind of a higher power, a political entity perhaps, to come in and help everybody get over those hurdles. So I think, you know, that would be my big picture take. I'm kind of the new kid in town, but that's my take from my conversations with people who were involved in that last project.
Okay, thank you, Jan. Brenda, having heard what the others have said, where do we go next?
Well, I do just want to comment on both what Dave and Jan just said, because I think they're hitting on something that I didn't talk about because I only had 7 minutes, but just kidding.
It's my fault.
The South Bay Salt Pond project, Diane Feinstein championed that project. Love her or hate her, she championed that project. She brought, I think, Dave, correct me if I'm wrong, $100 million into that project. I think, although don't quote me on this, Barbara Lee was a very big backer of the Oakland deepening project that resulted in the Middle Harbor program. I wasn't present in 1996 when Hamilton was sort of cooked up, but I know it involved a gentleman from NOAA Fisheries being incredibly supportive of developing the project, and I know that it was a congressional authorization to make the project go. And so, and I absolutely wholeheartedly agree with both of them that capital dredging projects really help, because when you think about maintenance dredging, you're dealing with a maintenance funding stream, right? And a capital project brings a different funding stream and a different level of political and regional activity. So those, you know, I'm not necessarily saying that we should go create a whole bunch of new capital projects to fund beneficial reuse of dredge material. I think that we do need to continue to have a national political push to fix some of the challenges that we face regionally. And I hinted at this, but I know for a fact from the coastal states organizations, the problems that we suffer from on the NAM programs that would like to see similar changes such that we can, as a resilience matter and a habitat recreation matter. So I think, you know, level and really building those coalitions to make this go, because I think as we talk about sea level rise adaptation, whether it be having some resilience for some period of time. And so just talking to them about it last night, about what we know about funding and how much things cost, and hopefully we'll have that out sometime early next year. But just even putting it down cost-wise, what we think we need is a good place to start.
Very good. Brenda, if I would very much like to see that white paper, if you can include me on your list there, I think that would be very useful. I don't know if Colonel Cunningham is still with us. Colonel?
I am here. Thank you.
So we have opposed a national strategy here, and I thought that it might be helpful if we could hear from you about where we go from here.
Well, sure. You know, I think those were really great recommendations and comments. And, you know, the one maybe thought that I would add to that is that there is a practicability aspect to everything that we have to do. And I say that in terms of cost. And I think the better that we can drive cost into a way that would allow these things to more readily happen inside of, you know, the appropriations that are available, whether that's the state, local, or the federal level, I think the better success that we'll have. I failed to mention, you know, one of our partners down on the South San Francisco Bay shoreline is the Coastal Conservancy. And I think one of the arrangements we have with Port of Redwood City for disposal of the dredge material to go upland is because of the partnership with them and some of the funds that we got on that specific channel. And so there are ways that we can bring together the various interests. And my argument would be that we need to look for ways that we can turn these into win-win scenarios where each of the participants accomplishes the objective, whether that's a wetland restoration project or a development project or in the private partnership model. There has to be some type of an economic driver, I think, to allow all of these things to happen. And it needs to be a cost efficiency associated with the option to take things upland. And I think that those opportunities come when we can align a land-based, a shoreline infrastructure type project with a navigation project. And I think you heard from some of the day's prior speakers. I mean, the costs are high in the Bay. You look at this national navigation program, we're significantly more expensive than other regions. And so it is, those are difficult conversations to have at the decision makers, in terms of costs and justification. But again, the economics of the ports and the benefit they provide are there. So I just think in order to make the argument for upland, we need to kind of tie all of those pieces together. Over.
We lost you, Colonel. Okay. Let me just, one last thing. Colonel Cunningham, you and I were talking to Peter Dreyfus, who spoke yesterday to us. Peter is one of the principals of a single operator dredger, the Watermaster, which is now being built in Michigan for a Jones Act application. Tulane University just came out with a study about the high cost of dredging in the United States, and I passed that on to all the participants. Do we need to maybe focus on making our dredging fleets more up to date? Your colleague in New Orleans, Colonel Murphy, said that there's a shortage of dredgers. There's more demand for dredging, and that is causing the costs of dredging to go up at a time when there is going to, and we're hearing about it all over the country. We heard about it from Louisiana, from Texas, and we're hearing about it here. We are going to have much, much more dredging to address the sea level issue. Do we need to start modernizing our dredging fleet?
That's a great comment. I certainly concur with Colonel Murphy and the New Orleans team. We had to mention economics, and it really comes down to supply and demand. We have fantastic industry partners, across the nation and in the Bay Area in particular, and there's plenty of work to go around. I think, when we look at the core owned dredging fleet, I think that adds a complementary capability to that mix. And so I do think that there are efforts underway to look at, I think some of the Gulf servicing or the Gulf servicing, federal dredge, and maybe eventually the West Coast servicing dredge. And I think that those are very, very important capabilities to have. They're more flexible in general than the contracting means. They're not a substitute for, nor do they have the capacity to handle all of the needs in a given year. And so I think, yes, I mean, it's a short answer. And then I know some of our industry partners are investing now too in new dredges too. So long answer to a short question, but I agree wholeheartedly. And I think that the more capabilities and the more participants out there, the better we're all going to get outcomes.
Very good. Okay. Guys, I want to thank you very much. We've gone a little bit over time, but I think to really a good end here. And I really like this final conversation because it gives us a strategy that I think Brenda suggested or gave us an overview for. Colonel Cunningham has given us some direction about some of the things that we need to do on the federal level. Jan, you've talked about the port role and how that can work. And Dave, you're on the receiving end from the salt pond challenges that you have. So thank you all very much. We are going to make the recordings available. Todd will be working on that. We'll also make the PowerPoints available very soon. Todd, we'll have those up. Can we have those up tomorrow?
Probably take a little longer because I've got to go through and edit them all. We're going to do all the panelists and separate it, but it shouldn't take too long.
The PowerPoint, I was talking about the PowerPoints.
Oh, the PowerPoint. So yeah, can do that.
Okay, very good. So we'll get that out to you guys. I want to thank all of our sponsors for supporting us, the Society of American Military Engineers, the Propeller Club of Northern California, our port partners. Thank you all, Brenda, Jan, Colonel Cunningham, Dave, and Brad. Thank you for our final panel. And we look forward to seeing you next year, hopefully live, but maybe like this. So all of our best wishes. Thanksgiving is next week. Good Thanksgiving under very trying circumstances. All of you guys are on the front end of the resiliency and sea level challenge. My best wishes and heartfelt hopes that you will succeed, and have a good holiday season, and let's hope for a better 2021.
Thanks, Stas.
Yes, thank you for organizing.
Thank you, guys.
Bye, everybody.
Bye.
Bye-bye.